Friends, welcome to Bank Exam Cafe, and in today's episode we are going to see once again few more questions from some applications of trigonometry. This is the part 11, and previously we have uploaded 10 parts, and the links of all these 10 parts are provided in the description box. You can go through all this video so that you will come to know which type of questions are being asked in the examination and how to deal with such questions. Now this is the part 11 of some applications of trigonometry. So let us move to the first question of the day. Friends, here is a question on the screen. As observed from the top of a lighthouse 100 meter high above the sea level, the angle of depression of the ship sailing directly towards it changes from 30 degrees to 60 degrees. Determine the distance traveled by the ship during the period of observation. Friends, in the question it is said that there is a lighthouse. Let AB is the lighthouse whose height is 100 meter, and from the top of the lighthouse someone is observing the ship. Let the ship be C, and the ship is sailing towards the lighthouse, and this angle of depression of ship C from the top of the lighthouse is 30 degrees. When the ship travels some distance towards the lighthouse AB and it approaches to point D, that time the angle of depression changes to 60 degree. It means the angle of depression initially is 30 degree and then it becomes 60 degree. It means that the angle of depression is increasing. It means the ship is traveling or sailing towards the lighthouse AB. And we have to find the distance between C and D, its original position of the ship and the present position of the ship, this distance. So let this distance be x. We will assume that this distance is x. Now you know that this is the straight eyesight and this is the ground, and these two are the parallel, and since these two are the parallel, AC is a transversal, and therefore this angle and these two angles are alternate interior angles, and the alternate interior angles are always equal. So if this angle is 30 degree, this angle will also be 30 degree. Similarly, this is straight eyesight and this is the sea level. So these two are parallel to each other. So AD will be the transversal, and so this angle 60 degree and this angle, these two angles are alternate interior angles, and the alternate interior angles are of same measure. So if this is 60 degree, this will be also 60 degree. Now friends, here we get the two triangles ADB. This is the right angle triangle, and triangle ACB. This is the another right angle triangle. With the help of these two right triangles, we can find the distance between C and D. So first we will take the triangle ADB, and therefore in triangle ADB, here in this triangle ADB we have tan 60, that is equal to opposite upon adjacent. AB is the opposite side and DB is the adjacent side, so it will be 100 upon DB, and therefore tan of 60 that is equal to 100 upon DB. Now here tan 60, that is root of 3, that is equal to 100 upon DB. Take DB to this side and root 3 to the other side, and you will get DB, that is equal to 100 by root 3. So this is dB is equal to 100 by root 3 meter. Let this be equation number 1. Now we will take the another triangle. In the another triangle, that is in triangle ACB. in this triangle, in triangle ACB, in triangle ACB, here tan of 30, that is equal to opposite side upon adjacent side. Opposite side is AB, that is 100 meter, so it will be 100 meter. Upon the adjacent side will be CD plus DB. This total will be the adjacent side, so it is X plus DB. X plus DB. Now here we know that DB is equal to 100 upon root 3. So we will put the value of DB as 100 upon root 3. So before that, put the value of tan 30. Tan 30 is 1 upon root 3. 1 upon root 3, that is equal to 100 upon X plus DB. Cross multiply. I do this here. So cross multiply and you will get X plus DB. X plus DB, that is equal to 100 into root 3. Now put the value of DB as 100 upon root 3. So X plus 100 upon root 3, which is equal to 100 root 3. So X, now take 100 upon root 3 to the other side. So that will be X is equal to 100 root 3 minus 100 upon root 3. Solve this further. So take the LCM. Root 3 will be the LCM. So X is equal to multiply by root 3 here. So root 3 into root 3 will be 3. 100 into 3 will be 300. So it is 300 minus 100 upon root 3. And so X is equal to 200 upon root 3. 200 upon root 3. So rationalize this, because we do not write surds in the denominator. So 200 multiply by root 3 to the numerator and root 3 to the denominator. So you will get 200 root 3 upon root 3 into root 3, that will be 3. And so if you put the value of 1.732 of root 3, you will get it as 200 into 1.732 upon 3, and if you solve this, you will get the answer 115.46 meter. Friends, here at the end you have to write the answer. So you will write the answer: the distance traveled by ship, the distance traveled by ship, the distance traveled by ship during the period of observation, that is equal to 115.46 meter. So here we have got the answer to the first question. Now let us move to the second question. Here is the second question. The two ships are there in the sea on the either side of a lighthouse in such a way that the ships and the lighthouse are in the same straight line. The angles of depression of two ships as observed from the top of the lighthouse are 60 degree and 45 degree. If the height of the lighthouse is 200 meter, find the distance between the two ships. Friends, it is given in the question that there is a lighthouse. Let AB is the lighthouse, and on the either side of the lighthouse the two ships are sailing. One ship is C and the another ship is D. Both are on the either side, means on the opposite sides of the lighthouse. And it is also said that all these three, means the ship C, the foot of the lighthouse, and ship D are on the straight line. And from the top of the lighthouse, someone is observing the ship C, and the ship D. The angle of depression when someone observes the ship C, the angle of depression formed is 60 degree, and when someone observes the ship D, the angle of depression formed is 45 degree. This is given, and it is also given that the height of the lighthouse is 200 meter. The height of the lighthouse is 200 meter. Now here we know that this is the straight eyesight and this is the sea level. These two are parallel to each other, and therefore AD is the transversal. AD is transversal, and therefore this angle 45. So this angle also be 45 because of the alternate interior angles. Similarly, this angle is 60 degree, so this angle will also be 60 degree because these are alternate interior angles. Now here we get two triangles ABC. This is the right angle triangle ABC, and another right angle triangle is ABD. We will use these two right triangles to find the distance between the two ships, means the distance between the point C and the point D. So here first we will take the triangle ABD. In triangle ABD, in triangle ABD, here we have tan of 45 is equal to opposite upon adjacent. Opposite is AB and adjacent is BD. So tan 45 that is equal to opposite is 200 upon adjacent is BD. Now tan 45 is 1, so which is equal to 200 upon BD. Now take BD to this side and you will get BD is equal to 200 meter. So BD that is equal to 200 meter. So we have got this length as 200 meter. This is also 200 meter. Now we will find the distance CB by using the triangle ABC. And so let us take the another triangle, that is triangle ACB. So in triangle ACB, in triangle ACB, what we have in triangle ACB, tan 60 that is equal to opposite side upon adjacent side, tan 60 that is equal to opposite side is AB and that is 200 meter. So it will be 200 meter upon adjacent side is BC. We know tan 60 is root 3. So put the value of tan 60. So it is root 3, which is equal to 200 upon BC. And therefore cross multiply and you will get BC is equal to 200 upon root 3. So this is 200 upon root 3. We will rationalize this, and therefore that is equal to 200 root 3 upon root 3 into 3, that will be 3. So 200 root 3 upon root 3, that is BC, and BD is 200 meter. BC is 200 root 3 upon 3 meter. If you put the value of root 3 here only as 1.73, then you will get that product and divide by 3, then you will get it as 115.33 meter. And therefore the distance between the two ships, that is equal to BD plus BC, that is 200 plus 115.33, and if you add these two, you will get it as 315.33 meter. So at the end you will write the answer that the distance between the two ships is equal to 315.33 meter. So friends, I hope you must have enjoyed this video. If yes, please like the video, share it with your friends, and do not forget to subscribe the channel. Also press the bell icon so that the notification of the newly uploaded video will reach to you and you will not miss any of the video. So friends, thank you very much for watching this video.